You might be feeling completely overwhelmed right now, drowning in the complexity of this topic. Maybe you're even thinking, this just isn't for me. Don't worry, you're not alone. I was once staring at the same pages, stuck in the exact same deadlock. But today, we're going to untangle this knot together. In this video, I'll explain those seemingly intimidating formulas, which, believe me, are actually based on just a few fundamental principles, in the simplest way possible. By the end of this video, you'll be amazed at how much lighter that big burden feels. And the secret to true mastery is simple. After watching this video, by solving just 20 intermediate and 5 advanced questions, we'll transform this topic from learned into a mastered skill. If you'd like more practice, let's connect in the comments. If you're ready, we're finishing this today. Let's begin. How do materials breathe under pressure? In the world of engineering, nothing is truly rigid. Every material stretches, shrinks, and twists. This is the language of deformation. This is the Generalized Hooke's law. In this video, we'll address exactly this, but first, let's make sure you know these basic formulas and fundamental concepts. If you are, let's begin. In the problem, when you apply stress to an object, it expands or contracts in 3 axes. Not in the case of constraint, of course. Visualize this with simple logic. Let's call this contraction or expansion strain and denote it with epsilon. Let's pay attention to these concepts, and these are our formulas. You should know these formulas very well. We will also discuss the formulas for applying strain in part 2. That's actually all for now. I'll solve 2 more examples to help you understand it better. Let's look at a practical example. We have a structural steel rod with a Young's modulus of 200 gigapascals and a Poisson's ratio of 0.3. The rod is pulled along the x-axis with a tensile stress of 250 megapascals. Since there are no other loads, our stress in the y and z directions is 0. First, we calculate the strain in the direction of the load. Using Hooke's law, we divide the stress by the modulus of elasticity. This gives us a longitudinal strain of 0.00125. But what happens to the thickness? Because of the Poisson effect, the rod contracts sideways. By applying the generalized formula, we find that the strain in y and z is negative 0.000375. The negative sign confirms the material is thinning as it stretches. Simple, yet essential. One load creates deformation in all 3 dimensions.